functions and non-acute angles. These are my angle, but the reference angle is formed between the x-axis and the terminal side of my angle. In the third quadrant, again, this whole thing right here is theta all the way to here. And here is the terminal side of my angle. But the reference angle is from the x-axis down to that terminal side. And when we're in the fourth quadrant, then the angle, loops all the way around here, greater than 270 degrees. But the reference angle is from, in this case, the positive x-axis to the terminal side. Very, very common mistake is to use the angle and go up to the y-axis. We don't do that. We always measure back to the x-axis. Now let's find the reference angle for 218 degrees. Now the first thing you always want to do is to, of course, draw your angle. 218 degrees is in the third quadrant. So you see your reference angle is going to be made by taking 218 and then subtracting 180, because that's this positive x-axis. So the reference angle is 38 degrees. Now what if you want the reference angle for something like this, 1387? Well, we once again have to find a coterminal angle between 0 and 360. And if you divide these out, 1387 by 360, you get about 3.9. So we know we're going to need to subtract off 360s. So we get 307 degrees. When I take the angle 1387 minus 3 times 360, I get 307. So the reference angle for 307 is 360 minus 307, or 53. Now we use 360 because this was in quadrant 4. And if you'd drawn it first, you would have seen that very clearly. Now let's look at the summary chart. In quadrant 1, the reference angle is just the angle. Because again, you remember the reference angle is an acute angle. In quadrant 2, it is, what is this right here? This is 180 degrees. So it's 180 minus the angle. Do you see how we're going clockwise here from 180 back up to the angle theta? In quadrant 3, here is angle theta all the way around here, and this is 180. So to find this reference angle, it's, what is it? It's theta minus 180. Again, we're going clockwise. When we're in the fourth quadrant, here is my angle theta all the way around here. So this is not 0, but we're going to call it 360. So to find this reference, it is 360 minus theta, because again, we're going to go clockwise to find that. That's just a trick I found to help you find reference angles. Let's find the values of the 6 trig functions for 210. The first thing you need to do is to find the reference angle. So 210 is in the third quadrant, and the reference angle is 210 minus 180, or 30 degrees. Now, we can pick a point along this line. So the distance from the origin to my point P is 2. Why 2? Because I know I've got a 30, 60, 90 right triangle on my hands. You could just use P and work through symbolically if you wished. But let's pick a point so the R value is 2. And then x is minus the square root of 3, and y is minus 1. Remember from our 30, 60, 90 rules. So the sine of 210 is minus 1/2 because it is, what is it, y over r. Cosine of 210 is minus root 3 over 2. Tangent of 210 is minus 1 over minus the square root of 3, canceling out our negative signs and rationalizing the denominator, we get square root of 3 over 3. Cotangent of 210 is just the square root of 3. Secant of 210 is 2 over minus the square root of 3. Again, rationalize the denominator, so you get 2 root 3 over 3. And cosecant is minus 2, okay, which is really, you could do the inverse or the reciprocal of sine of 210 to do cosecant. You can also do the reciprocal rules for all of these. Now, let's look at some rules for finding trig functions for any angle. Okay, if it's greater than 360 or less than 0, find a coterminal angle by adding or subtracting 360 as many times as you need to get an angle that's greater than 0 but less than 360. Then find the reference angle, and then find the trig function values for that reference angle. Make sure you determine the correct sign. You can use the quadrant method or any method to help you figure those signs out. Of negative 240. Now we have a negative angle, so we do need to find what angle it's coterminal with. So if I have negative 240 and I add 360, that gives me 120 as the positive angle. If I were to measure it this way, that would be 120. So if this is 120, the reference angle is 180 minus 120, or 60. So we're in the second quadrant, so I know my y value is going to be positive and my x value is going to be negative. So the cosine of negative 240 is the same as the cosine of 120, which is the same as negative cosine of 60, where this is my reference angle. And remember, we memorized that the cosine of 60 is 1/2. So the cosine of minus 240 is minus 1/2. Find the exact value of the tangent of 675. Now 675, if I divide by 360, I'm going to see that that's 1 point something. So I'm going to subtract off 1 360 to find the coterminal angle of 315. So if my angle is 315, then my reference angle is 360 minus 315, or 45. The tangent is going to be negative in quadrant 4. So the tangent of 675 is the same as the tangent of 315. The tangent of 315 is negative, because it's in the fourth quadrant. Tangent of 45, the reference angle, or negative 1. Now let's evaluate the cosine of 120 plus 2 sine squared of 60 minus tan squared of 30. Now we're going to do all this without a calculator. Now, you should by now realize the cosine of 120 is minus 1/2. The sine of 60 is root 3 over 2. And the tangent of 30 is root 3 over 3. So when we substitute this in, cosine of 120 is minus 1/2 plus 2 times, and we're going to have to remember to square everything here. So if we have sine of 60 is root 3 over 2, we're going to need to make sure we square both the root 3 and the 2. A lot of students forget to square that term. And then minus tan squared of 30, which is root 3 over 3. So when you do a little algebra and simplify, you get it is equal to 2/3. Now, evaluate the cosine of 780. When we divide 780 by 360, it's 2 point something. So let's find the coterminal angle. Find the coterminal angle, we're going to find the cosine of 780 minus 2 times 360. So that is 60 degrees. So cosine of 780 is coterminal with the cosine of 60. And we're looking for the cosine of 60, which is 1/2. Cotangent of negative 405 by first expressing the function in terms of an angle between 0 and 360. All right, so to find the coterminal angle, when I divide 360 or 405 by 360, I get 1 point something. Now, because this is negative, I'm going to add 1 to that. So I'm going to look at negative 405 plus 2 times 360. That's where I added the 1. So this becomes cotangent of 315 degrees. Now this is in quadrant 4, and the reference angle is 45. So the cotangent of 315 is equal to the cotangent of negative cotangent of 45, or negative 1. Now find all the values of theta if theta is in the interval between 0 and 360. And we know that the cosine is minus root 2 over 2. Now, since cosine's negative, we know it's got to be in quadrant 2 or quadrant 3. So it's got to be here or here. Now, the absolute value of the cosine is root 2 over 2. And that tells me my reference angle is 45. So the angle in quadrant 2 is going to be 180 minus 45, or 135. Remember, it's 180. And then here is my reference angle. So I'm going to subtract those to get this angle right here. The angle in quadrant 3 is 180, and then we're going to add plus the reference angle of 45 to get an angle of 225. So in between 0 and 360, the cosine of theta is minus root 2 over 2 at 135 and 225.